As a UTME candidate, you should be able to know the two ways of classification of wave motion. The first way you may wish to classify this wave is based on the medium of propagation. The second way is the direction of the wave medium respective to its vibrating point. Now let's go over to this part. In the medium of propagation, we are going to have two different types of wave. Here we can classify them as mechanical wave. We classify also as electromechanical wave. Now, mechanical wave, like we're talking about medium of propagation, will require a material medium. What I mean by medium is maybe the air or a place where something can be able to act on. For example, this air is a medium, the wall is a medium, water is a medium. I get it. Now, the wave that will require a material medium are classified under mechanical wave, while those that won't require any material medium, they can go on their own, is known as electromagnetic wave. Now, example of those waves that requires a material medium are, for example, we have water wave, whereby the medium of the propagation is going to be in the water. All right. We also have sound wave. In sound wave, the medium of propagation is going to be the air. This air is a medium whereby the sound propagates. So without the air, you cannot hear what I'm saying. Now, the third one, we could also classify it based on the wave on a rope. Wave on a rope. Wave on a rope. So wave on a rope, you can see that the rope will become the propagation point or the medium through which that wave in the rope will propagate. Now these are under mechanical wave that requires a material medium. Now under electromagnetic wave that won't require a material medium, we could have example as light wave. We also have another one as S-rays. We also have radio wave. We could also have gamma ray. So these I have classified based on what medium of propagation. Now the second one will be based on the direction of the wave motion respective to its vibrating point. In this case, we are going to have two types of wave. Here we have a transverse wave, and here we have a longitudinal wave. What do we mean by the direction of the wave? For example, if I should disturb a wave here and you start seeing that wave moving in this form, as you can see that this wave motion that you are seeing here, it is perpendicular to the point of vibration. There is another way to have a string in this form. Now this string that you're seeing here, let me say I tie this part in a wall, and here I expanded this part and release the thing that is going to compress and again expand, compress and expand until it cools down. What happened? I have vibrated this wave here, and as you can see, the wave direction or the wave motion occurs in the same direction with the vibration. So I disturb it by expanding it in a straight line, and the wave is also vibrating also in a straight line. Now the wave in which the direction of the propagation are perpendicular to the point of vibration is what we note as transverse wave, whereby those that travels in the same or the direction of the travel occurs in the same line of propagation of vibration is what we note as longitudinal wave. Now from here, the transverse wave is the same thing with an electromagnetic wave, so that we are still going to have the same thing we have here as light wave, radio wave, also S rays, gamma rays are all transverse wave. So transverse wave are also what? Electromagnetic wave. But in transverse, we are talking about how they propagate. In electromagnetic, we are talking about how the medium of propagation. All right. Now, longitudinal wave, which are waves that travel perpendicular to the point of vibration, are also the same thing with mechanical wave. So you have to know that all mechanical waves are longitudinal wave. Hence, mechanical wave travel in the direction perpendicularly to the point of vibration. So we can also have the same thing as sound wave. We have the same thing as water wave. We have the same thing as wave on a string. We also have the same thing as wave in a rope. So this is what you have to know. Don't be confused when you are asked the longitudinal wave. Don't be confused when you are asked the transverse wave, or don't be asked which of these is a mechanical wave and you are given a longitudinal wave. It is still the same thing. So note the two terms. These terms belong to the medium, and these two terms belong to how they propagate. Thank you for watching this first video on wave. Let's talk about the real diagram on wave on our next video.